We're going to switch now from the spectrum analyzer mode over to master mode, which is the second tab from the left on the top. And we have set up one master talking to one relay node. The master is node 0 always. And the first node to be acquired by the master is given node number 1. And you can see his friendly name. He's on top of the speaker, so that helps you keep track of where things are. You can also see the outbound frequency or channel that the master is transmitting on. And you can see the inbound frequency that he's receiving on. So you have both an outbound signal which carries the audio, and you have an inbound signal which carries control data from each of the remotes. The remote in this particular case is actually transmitting on channel 2, but no one's receiving him. He's not actually relaying a signal yet, but it's out there being broadcast, so that any other relays that happen to look for a signal that are not within the range of the master would pick up his signal. So this guy could be 300 feet away from this guy, and the next guy down could be another 300 feet, so he would not see the master, but he would see relay number 1, node number 1. So what we have here, I'll just run through the screen top to bottom. The master transmit receive frequency selection is done up here. When it's in the auto mode, you do not have control over changing these channels. But when you're in the manual mode, you do. And you need to be careful when you do that, because any change of channel will cause anybody who's actually receiving this signal to have to research for a signal. But that typically is fairly quick. Transmit power you typically leave at plus 20 dBm. You typically don't want to change that unless you're forced to put nodes very close to each other. The UCC, the uplink control channel, is shown here. That again is this channel, and that's where the control information comes from any downstream nodes. This section is the master audio section. We have a graph, LED graph showing the audio coming into the unit, and we have an input gain control that allows you to change the gain. If your audio level is kind of low, you can bring it up 20, 30, 40 dB. We have an audio mute that basically mutes the output from the master to everyone in the network. We have a compressor here that's typically used for highly variable audio, like an announcer that tends to yell and scream. You can compress him. But for audio, it tends to make it flat, so we typically like to keep the compressor off, but it's there to keep you from having obnoxious peaks in the audio. This is the audio input connector mode. You'll have to read through the user guide to really see the differences here, but typically balanced mono is the XLR input. You can have unbalanced mono if you have just a single pin on the XLR active. And we actually take a stereo signal in unbalanced stereo, and we mix the left and the right channel together to create a single audio channel for transmission over the air. So that's the difference in these different connectors. In the center of the screen is the network map. Any nodes that are in the network communicating with the master will show up here. And you can actually zoom in and zoom out if you need to. And expand your network size by scrolling the mouse wheel. The other thing that we can do is we can drag these guys around. Now, right now we have auto layout turned on, so if you drag them, they tend to come back to where they were. But if you want to turn auto layoff off, you can actually drag these guys around to be, you know, more like your physical venue setup, so that you can keep track of them, especially if you get more nodes on here. We'll turn this back on so that they kind of rubber band back to their original place. On the right, what you'll see over here is the actual received signal level at the node being monitored. So we've clicked on this guy, which means we're monitoring node 1 in this screen. And his RSSI, or Received Signal Strength Indicator, is shown in this small graph. The next graph is the number of missed polls. So the master is continuously polling each node in the network. And if he drops a poll and we know he didn't respond, we'll get a blip here. Having an occasional drop poll is not a big deal. What you'll see is if they start losing signal, this polling percentage of missed polls will go up, and he'll eventually have to reacquire signal. So you need to keep an eye on that. If you see lots of dropped polls, you're probably getting interference of some kind. On the bottom is the packet error rate, which means the number of dropped packets that this guy detects that he did not receive. In other words, he knows when he should have received a packet from the master. If that packet does not show up when it's supposed to, he will indicate that he dropped a packet, and he'll report that back to the master. And when you see a little blip here, that means there actually is a drop packet, which means there is a dropout in the audio. So if you've got a significant number of these, then you've got a problem. You've probably got some interference, or you're too far away from the master, or some other issue is going on, and you may want to look at the frequencies that you're using and change those if you continue to get a packet error rate that's above whatever your acceptable limit is. Along the bottom, you've got several functions here that we'll run through separately. The open the monitor window we'll do next, but it's basically opening up his front panel so that you can see all the detail and control everything. Open network, we'll talk about network security a little more, but an open network is one in which any node that is an ARX 200 can participate in the network. If you close the network or secure the network, only the nodes that have been registered in your database will be able to communicate with the master. So that's your network security. Somebody that just owns an AiRocs unit that happens to show up at your venue would then, who is not registered in your database, would then not be able to participate in the network. So what we do typically, as we deploy, we leave the network open. Nodes that are not registered will show up in red, and nodes that are registered will show up in white, like this one. And once you start the live part of the performance, you can secure the network so that nobody else can participate. Auto layout we just showed. ALO we will talk about in depth later on, but just as an overview, ALO stands for Automatic Link Optimization, which basically means that if this guy who's 300 feet away detects that his packet error rate has exceeded an acceptable threshold, he will go offline. He will scan the local RF spectrum in his area, and he will come back online and report that to the master saying, here's a better channel, please switch to this channel if possible. We typically leave ALO off at the master, but we enable it by default on all of the relays, so that if the third node down here has a problem, he can tell this guy to switch, and if he's the only node connected, that switch happens fairly transparently and automatically. So ALO is a very powerful tool for allowing you to keep track of any changes that occur in the interference level at every location in the network. Again, the master tends to talk to more than one guy, so you may or may not want to allow ALO at the master site. Polling is a way of telling who's connected. If you turn that on, you'll get a list of the nodes. Here's node number 1 is being polled by the master, and each of these guys has a poll list also. This is just for helping you debug network issues, but the problem with it is it sends out an extra poll, which can get somewhat unwieldy in large networks. So we tend to leave it off, which means that you can see here who's being polled, but if you want to actually display them for each node, turning them on causes a doubling of the polling traffic on the network. And as the networks get larger, that could slow down the network response and cause things to look sluggish. And you've got a radio temperature. It's just an internal temperature of the radio itself. You can typically operate up to 140, 150 degrees Fahrenheit with no problem. Beyond that, you need to be a little careful of what the temperature is. But typically, there's about a 20-degree rise, 10 to 20 degree rise inside the unit from the outside. So you can operate much longer than people are willing to stay in a venue and listen. Let's put it that way. So what we can do here now, we'll open a network monitor window which will show us what's inside of this guy. So we'll go ahead and do that, and then we'll switch to another video to show the details. But this is basically the network monitor window, which is the front panel of that remote unit, and we'll go in detail in that in the next video.